Okay, so number 1 is 4, right? Because a negative times a negative makes a positive. How's about Kayla? What'd you get for number 2?
-8.
True, because a negative times a negative times a negative takes you back to a negative. So when you have an even power, positive. When you have an odd power, negative. All right, next one. Natalie's not here today. Rowan.
16.
True. Even power, even answer. 2 times 2 times 2 times 2, 16. All right, last one. Sigh. Danielle, what'd you get for the last one?
2, and then the thingy, and
The thingy.
the square root.
What happened here? All right, so 24, right? If you don't know how to do this, you break it down. 2 times 12, right? And then 12 is 2 times 6. And then 6 is 2 times 3. So we have 2, 2, 2, 3. Every group of 2 can take one out. The 2 and the 3 left on the inside get multiplied together. No, not right now, buddy. I want to stay focused. Maybe later, though. I do love jokes. All right, here we go. Now we're going to do a guided practice together. Guided practice. Here we go. Number 1.
Wait, is this unit 6?
Yeah, it's like a warm-up, the beginning. Like it's an introduction.
Wait, so are we going to write anything?
We will. We will. We'll get there. Yeah. So what's the answer?
2.
Okay, number 2.
Oh, I, and then it's radical.
It's just 2.
Oh, 2I.
Yeah, so if you guys forgot how this works, what you do is you start, when you have a negative under a square root, you take out the imaginary number, and then you do the square root like you normally would. I times 2 is 2I, right? So that's how you deal with that. Now, I don't know if you guys are familiar with this, but I'm gonna throw something new at you. You're right, it is. All right, so now this is not a square root. This is what Rowan said. This is what we call a cube root. Now, technically, I could have put a 2 here, but we don't. You don't do that with square root. But what that little number there means is that means you're looking for groups of 2 things that are the same, and then they can have a baby turtle, and then they leave, right? But some of you guys might already know the answer. Does anybody know the answer? It's 2. Now, let me show you why. We start by breaking down 8 like we normally would, right? Now, it's not a square root. It's a cube root. So I'm going to put a little 3 right there. And there are 3 2's. And remember our little story about how a mommy turtle and daddy turtle love each other very much? They have a baby turtle and then they leave. Well, in this story, it takes 3. Yeah, I don't know. We have to get away from the analogy at this point because it gets dirty. So we're just going to say these 3 have a baby too, and then they leave.
Oh, he has 2 baby mamas. Guys, false alarm, he has 2 baby mamas. It's okay.
So the answer is 2.
Wait a second. Hey.
All right, next. Pay attention now.
Oh, wait, are you recording?
What's the answer?
Wait, are you recording?
It's an I.
You want to say 2I, but it's not.
It's because they. Wait, it's not.
It's not. Now, I got some side conversations over there, John. So I want to make sure you guys get this. So the answer is not 2I. I is because that was up here. That was because this is an imaginary number. There is no number that multiplies by itself to make -4. That's impossible. But there is a number multiplied by itself 3 times to make -8. What is it? -2. Okay, so here's how, when you have an odd root, here's how those ones work. Okay, it's not like when you have an even root. Okay, when you have an odd root like this, instead of taking out an I, You just take the negative out. That's it. It's actually a real number. Because we saw in our beginning, right? What's negative 2 times negative 2 times negative 2? Negative 8. So there is a cube root of negative 8. It's not imaginary. The cube root of negative 8 is negative 2.
So do we do that anytime I give it, say, it was a 4, do we bring the negative out?
Yeah, yeah. So here's the thing, but here's when you don't, right? If you have a square root, you take out an I. But if you have an odd root, you take out a negative.
Oh, okay.
Imaginary, real. Okay? So, odd roots are different than even roots. Odd roots never have imaginaries. They're always real. They're either positive. If you start with a positive, you get a positive. You start with a negative, you get a negative. But with square roots, it can only have a positive real answer. If you have a negative in there, it's imaginary. So you won't be getting negative answers there. All right, so there's your aha moment. So here we go. Let's write this down. So I want you guys to let's write down our title now. This is Unit 6. Unit 6 is all about radical functions. Radical is the general word for roots, okay? So we know the square root, and I just taught you about the cube root, but there could be a fourth root, a fifth root, a third root, and then you can actually turn those into functions as well. So this whole chapter is about radical functions, equations that have square roots in them or cube roots or something like that, okay? Today's lesson was lesson 1, and it's going to be all about nth roots is what we'll call it. We have 2 objectives, really. 1, simplifying nth roots. And 2, I'll explain this one later. It won't make sense yet. But we're also going to talk about rational exponents. For example, x to the a over b power. So when your power is a fraction. All right, so we're talking about 2 things today. How do you simplify these new roots that are not just square roots, right? And then also rational exponents when you have a term with a power that's a fraction. That's a new concept for us, okay? So, here we go. Let's begin. Oh, you know what? Before we do that, let me give you guys a note here. So this is an nth root. This is what I mean by an nth root. Whatever kind of radical we're looking at, a square root, a cube root, what kind of root is it? Okay. We have to look at 2 things in order to figure out what our answer is going to be. First of all, my root can be even or it can be odd, right? Second of all, that number inside can be positive or it can be negative. So let me give you an example. So let's pick, I'm just going to do a regular square root, okay? So let's put a 2 here, okay? And then I'm going to put a positive number into here like 4. When you take the square root of 4, what kind of an answer do you get?
2.
You get a positive number, what, right? 1 real positive number. You get 1 real positive number. The square root of 4 is 2, right? What happened whenever I still had an even root, right? But I make the inside negative. What do I end up with there? I end up with 1 imaginary root, right? So we get 1 imaginary root. Now let's see, what did we figure out happened whenever we had an odd root, like 3, and I put a positive number there? What did I get?
You get a positive number.
We had 1 positive, right? So 1 real positive root. What happened when I made that 8 a negative?
You got a negative. Real negative.
I got a real negative root, right? So you get 1 real negative. Now, we're going to go ahead and start simplifying some of these types of problems. Well, that was just an example. You don't really need that. I was just using that to talk.
You've already done that one, no?
Huh?
You already did that one?
Yeah. All right. So let's do some practice problems. Wow, big numbers.
Oh my
Oh,
god.
cheese.
Cheese? There's no cheese up here. This is a number.
Please stop.
Yeah.
My brain already.
Are you calling my jokes cheesy, bro?
No.
Oh, that was
It's not about
cheesy.
you, joke. It's about that math number.
All right, write down number 1. This is example 1.
Oh my God.
Just let it out. It cleanses your lacrimal ducts.
What? I'm gonna cleanse your body.
First of all, guys, we got to break down this number here. So I know this is the sucky part. Just bear with me. What goes into 448?
Oh, wow.
2.
Probably
224.
2 does.
224 and 2. Oh, that's too big.
Oh.
No.
Now, just so you guys know, the bigger number you start with, like I know 4 goes in there, so I would have started with 4. Because if you pick a bigger number, it makes everything smaller afterwards. But that's okay. We'll do 2. What goes into 224?
112 and 2.
Okay.
Oh,
And then it's 67 and 2.
Close. 66.
Oh, and 33 and 2.
Getting there.
And then 11 and 3.
Now we're done.
Oh, finally.
Okay. So I'm going to rewrite this now. We have 1, 2, 3, 4.
So bring out, that's 4 outside.
4 2s.
111.
1 11. 1 3. And I've got 7 B's. Now I'm going to write this, but some of you guys eventually might find like a shorter way to write to this in your mind. I'm going to encourage you to do it if you know it. But I'm going to write it. It's going to be 7 B's.
Oh no.
Really?
That's cute.
Oh, come on. It's not that bad, you
Are we
guys.
gonna make it a phobia?
Took me like a whole 5 seconds.
It's a waste of Lego.
All right. Now I'm gonna change this problem because I don't like the outcome. Okay. Can you guys change this 6 for me? I don't like how this one's turning out. We could do it, but it's just kind of, it takes away what I'm trying to demonstrate for you guys. Let's change it to a 4, please. Sorry about that. Okay, now that little 4 there tells me how many should be in a group in order for them to have a baby. So we're looking for groups of 4 that can have a baby. Do I have any groups of 4 identical things?
2 and B.
So there's one, so let's circle that. Those 4 can have a baby too, and then they leave. And then these 4 can have a baby. B, they can have a baby B. Baby. Baby. And they leave. Nobody else can have babies.
No, that's
So, final answer, 2B, or not 2B. Don't forget, by the way, like I just did, don't forget to put your little 4 there, okay? What's left on the inside?
11.
Okay, so I'm going to put those all together. What would it be?
33.
11 times 3.
33 B's cubed.
There you go. That's how you. So what you guys just did was you took a 4th root. Okay, a 4th root is like a square root. Square root looks for something times itself that makes that number. What this is this is what you would have to take if you multiplied this expression by itself 4 times. You would get 448 beats.
That was kind of
Yeah.
Do you have the 4?
You do need to put the 4 because if you don't put the 4, what kind of root is that? It's a square root. So if you forget the 4, you're wrong. Yeah.
Why did you didn't bring out 4? You just have just 2 pairs of 2?
Because we're not looking for pairs anymore. This is a fourth root, so we're looking for groups of 4. So now it takes 4 similar numbers to make a baby 2. Yeah. You can, but would you know what to take out? Now I'll tell you how you can do this mentally. Ready? There's 7 B's, right? Can you divide 7 by 4? Yes, it goes in there once with 3 left over. Got it? So you can do that if you want. Just do the division. Remainder here, quotient here. All right, let's do another one. Okay, I want you guys to go ahead and break down. I think you guys might be able to handle this. On this one, we're looking for groups of how many they're the same? 5. All right, so go ahead. See if you guys can do it. 2. So what we call this, in case you guys are wondering how to say this when I call on you, is it's the 5th root. So 5th root of what? 3r squared. Okay. So wait a minute. I just told somebody they were right, but I think it was you.
Yep.
I think it's a 3, not a 6. So let's see why. So you want to break down your 96. What goes in there?
That's 48 and 2. 48 and 2 goes into 24 and 2. That then goes into 12 and 2. And that goes into 6 and 2. And that goes into 3 and 2.
Okay, calm down, please.
No. Which gives you
Call
a
him
2.
Satan.
Okay. Which gives you a 2 times 2 times 2 times 2 times 2 times 3 times r times r.
1, 2, 3, 4, 5 2s.
Yeah.
And then we have, don't forget your 3.
Times 3 and then times r times r.
And then we have 2 r's, right? And we only have one group of
2.
5 things.
Yes, those 2s have a baby when they leave.
One of those. Go for it, honey. That's fine.
And those 2s
Take
have
that
a
little
baby.
green pass up there. All right, so I've got 5 things that are identical. So I'm going to take out a 2.
Oh, and you're left with 2, 3 r.
There you
Kaboom!
go.
Math.
Yes, indeed it is. All right, let's do another one.
Is this how hard it's gonna get?
Mr. Baby,
Huh?
Don't ask that question. Remember last time we
Yes.
asked it?
and then he gave us help.
Would you guys please write down number 3, please? Here we go.
You're like,
So here's the key question. Shh. All right, now we have a negative in there, right? Now when you have a negative, you either take out an I or a negative.
We'll take out the
We take a negative out because this is a odd root. So when you have an odd, you take out your negative. That's the only difference. So here we go. We have negative 250 m squared. We're going to take out the negative. Like that. But remember, if it's a square root, we take out a what? If it's a square root.
But it's not square,
Take
so
out I.
it stays negative.
So in this case, we just take out the negative. And then from there, guys, it's really, thank you. From here, it's pretty much the same. I don't want to spend too long on the details here because after that, it's all the same. Let's see, 250, that's 25 times 10, which is
Or you can
2.
also do 50 times 4.
50 times 5.
I'm not going to show my work. I'm just going to put what you would get, right? Now, what can I take out? I've got 3 5s, so I'm looking for groups of 3 identical things, right?
Wait, hold on, Mr. Bailey. I did a different pair of numbers, and I got only 2 5s.
It's 3. I'll look at it with you in a second, though. All right, so the negative goes in front of the 5 that I took out. You got to be careful with this because if you put this 3 right here, guys, doesn't that look like it's 5 to the 3rd power? But it's not. So you got to be really kind of careful how you write that. I would tuck that 3 in a little bit further away from the 5 so it doesn't look like 5 to the 3rd because it's not. It's a 3rd root. And then what we have left on the inside is 2m squared. Okay? So just remember, odd roots, negative comes out, even roots, I comes out. We're good.
Okay, figure it out.
You got it? All right. Let me throw one more at you guys. This one's going to have a negative involved as well. I'm going to put a negative here. I want you guys to do number 4. But I added a negative, so go for it. Here's the big question. You ready? Heidi. Actually, this is not the big question. What kind of root is this, Heidi? Okay, that you answered the big question. It's a square root. Now, when it's a square root, the big question I'm going to come at Nathaniel with, when it's a square root, what do we take out? An I. You don't take out a negative. And then from here, we're going to break it down. So let me ask Jonathan. If I broke down 18, Jonathan, see how good your mental math is here.
All right, that goes down to 6 and 3.
Which is?
6 and 3, and then that would be 3 and 2, so that would be 2 3s, and then a 2, and then 4 R's.
Great. Okay.
See the outside of your word? Can I answer it?
No. Leslie, what can I take out here? A 3? What else? An R and one more.
Another R.
Another R, because there's 2 pairs of those, right? So I could take out a 3. I could take out a R and another R. So my final answer will be 3R squared I.
Oh, I put it in the wrong order.
Oh, so the I's
Kind of
last.
doesn't really matter,
Oh,
honestly.
it doesn't?
Not really.
Dang, Miss Barry, I just erased it.
There you go. But this is the order that you would see on a multiple choice test. They usually put the imaginary number right in front of the square root, then the variable comes after the coefficient.
Do not go forward. I'm still-
Ready?
What am I introducing this to? No.
What are we on? B?
I don't even know. We're on like 5.
No. For
Yes, B.
okay.
We never wrote A, so
Yes, we did. We
Okay,
did.
never mind. I guess I am.
Not again.
Let's talk about rational exponents for a second here. Now I'm going to write something, but you don't need to write it. I just want you guys to watch. All right, David, that story needs to stop now. Both you boys. Kenneth.
What?
That story's got to come to an end sometime. All right, here we go. So I don't want you guys to write this. I want you guys to just watch and pay attention. So I'm going to tell you that there is a number, and I'm going to raise it to the 1/3 power. Matter of fact, I'm going to give you a number. Don't write this. Once again, you're just watching. I'm going to ask you, what is 8 to the 1/3 power? Now, right now, we don't know. But what we're going to do is I'm going to show you guys some tricks here. So right now, do we know what that is? No, we don't. Now, let me show you. Now, let me show you guys what I'm going to do now. Ready? Now, I'm going to use a little rule about exponents to help me solve this problem. Do you guys know what this would equal if I had this?
Yeah, X is 10.
You multiply them, right? All right, so I'm going to use that little algebra fact to solve this problem. I'm going to figure out what this x is. Ready? What can I multiply 1/3 by to cancel the 3?
3.
You multiply it by 3. So I'm going to raise this side to the 3rd power. But whatever you do to one side, you do to the other, right?
Wait, that's it?
And so those cancel. And what am I left with on the left? So now this thing says, what number to the 3rd power is 8?
2.
It's just 2, right? 2. Now, there's another way I could write this. Instead of saying what number to the 3rd power equals 8, can't I just say that x is equal to the 3rd root of 8? You with me? So here's what I want you guys to take away from this. Ready? I'm going to get rid of this, and this, and this, and this. Here's what it is. Ready? When you have a number being raised to a fraction power, that bottom number tells you what root you're looking for. Okay? This number up here is a normal exponent, like it's 1.
What if it's like, so if it's like 3 or 4 or like 7,
You want to see another one? How about, let's say I had 5 to the 2/3 power. So this would be a 3rd root of 5 to the 2nd power.
Okay, that's easy.
That's all it is.
Everybody's tripping.
So, I'm going to give you something better to write. So I didn't want you guys to write that slide. Here we go. Let's go back to our original one here. Here's what I want you guys to write. Ready? Oh, I don't like that. Let's see. What I have there? I think it's A. So if you have some number being raised to a t over b, you can rewrite that like this. The b tells you what kind of a root you're taking. The t is your exponent. And a is what's having all this stuff done to it. Okay? Yeah, this you should be writing this. So, there you go.
Did you make up those like exponents like teams?
I did, because that means top, that means bottom.
Oh,
But also kind of works out cool so that when you're done it says back. Kind of easy to remember. To help you guys remember. It's not like it means anything useful, but it might help you remember it.
like
All right.
back when you want to swing at this lesson.
Now there's two ways you guys can write this answer. This is the one I'm going to use today, but after today, I'm going to use the other one. Here's the other way this could be written. B, A, and you can have the T on the inside. We're going to do that one. We're going to do that one later. But for today, we're going to use this one, okay? It could be either way. Sometimes it's easier to write it like this to get your answer. Sometimes it's easier to write it like this to get an answer. For the ones I'm giving you today, that's the one we're doing, okay? Tomorrow we'll do a few other types of, or not tomorrow, but Monday, we'll do a few other types. Can I proceed? Okay. So many problems here. All right. Would you guys please write down number 9, please? Yeah. So check it out. You ready? Now we're not going to actually figure these out today. We're going to do that next time. For today, I just want us to rewrite it. So it's going to look like this. What number goes here?
Yes.
The 2 does. And what number goes here? And then we're going to put this in parentheses and what goes out here?
1. Wait. Oh, that's a good. It's 3. I'm blind. I can't see.
Okay. Now, that's as far as we're going today. You could do more with this, but we're going to stop. Now, just so you guys know, when it's a square root, and let's say you're taking a multiple choice test, you won't see that 2 there. They won't have it. Because when it's a square root, they don't write it. Now, you can write it. It's not wrong, but they won't write that, just so you know. All right, let's go ahead and do the next one here. So I'm going to put, this is number 2. What's going on here? 4. In here? And out here. There you go. That's all I want you guys to be able to do today. After that, we'll do more. So what we've learned then is that when you have an exponent that's a fraction, it's really just code for roots. Okay? So, I mean, I'm sure you guys probably don't need to practice too much, but I'll still give you a chance to. Oh, you know what? I forgot. This is something else. I want to talk about this. So go ahead and write down this is number 3. I forgot about these. These are a little bit different. Write this one down. This rule is really hard for kids to remember. It's not a hard rule. It's just that it's hard for people to remember, okay? Because it doesn't make sense. So therefore, we don't remember it well. But here it is. If you ever have a number that's raised to a negative power, what that is it makes the reciprocal of that number. So a to the negative n is 1 over a to the nth power. Okay? So for example, if I gave you guys this, 2 to the negative 2, that would be 1 over what? 2 squared. So notice that the negative becomes a positive. So once you do the reciprocal, the exponent becomes positive, and then we can go a little bit further. What's that going to be? 1/4. So let me throw another one at you. How about 3 to the negative 2? What would that be?
1 over 3.
So final answer? 1 over, which is? There you go. Let's do one more. How about 1 over 3? No. Sorry, not 1 over.
So how do we do the fraction ones then?
We'll get there. How about 3 to the negative 3? What would that be? You guys good?
Yeah.
So 3 to the
Wait, no,
third.
well, negative 127.
No. That's the thing that people mess up on. So 3 to the third. 3 times 3 times 3 is
Oh.
27, right? So it's going to be 1 over 3 to the third. And 3 times 3 times 3 is 27. So here, the biggest mistake people make on this is they think that since the exponent is negative, the answer is negative. And that's not true. Negative exponents don't change the sign of your answer. They make it a reciprocal. That's all they do. So that rule's hard for people to remember because it's not easy to remember. So I write this down somewhere on your paper. So now, John, you were asking, what about this one then? So let's go back and let's do this one now. Ready? So the first thing I'm going to do is I'm going to rewrite it like this. I'm just going to make it a reciprocal. Henry, I'm ashamed of you. Now, we're going to change it into radical form. So that would be, what kind of a root?
3.
3, b to the 5th. There you go. That's it. Let's
Wait, that's disgusting.
let's do another one. Ready?
No, I'm not ready. Hold up. I have to write down the thing.
The thingy, because teachers don't usually teach it. All right, here we go. Step 1 is going to be what? So how do I write it?
1 over 6 and
4 thirds, but
Power.
yes.
I cannot really. I can't see.
Okay,
Sight lines.
now what? I changed what?
Unto the.
Don't say thingy.
But 3. Put 3 radical.
There we go.
6 and to the 4th.
Now, the right way to say it, though, Henry, is the third root. There you go. The third root, a.k.a. thingy, 6 in
4.
to the 4th.
To the thingy.
Wait.
To the thing.
So wait, he's making it positive again.
Yo.
Yes,
Someone,
but now it's a
Ah.
reciprocal.
graphic design needs to
I want
design this.
to go to the thingy. That's. I'm sorry, Mr. Bailey.
Look what you've done. Look what you've
I'm
done.
out of it
Actually, my
today.
friend
He's
take
making
this
a
now.
fraction. Go do it.
That's all. That is all it's doing.
Just because
You've brought it home, John. You're right. That's all it's doing. Okay, so I want to put a couple up here for your student practice, and then we're going to call it a day. Ready? So here's number 1. I want you guys to find out for me what is 5p to the 3/7 power. And then I want you guys to tell me what is 2x to the negative half power.
Dude, you have to like. Do we have to solve it?
That's that. Yeah.
I have to come back for 2 tonight.